Okay, so I want to do the quotient rule, have a video of that by itself because I realized that it might be overwhelming to try to think about both the product and the rule and the quotient rule together. So the quotient rule is about division. You have a function divided by another function. And there is this kind of sing-songy thing that you can do in order to remember it. I'm going to rely on the numerator being what I call the high and the denominator being what I call the low. And then every time you see a D, it means derivative. Okay, so this says pick up the low, which is just G, and then multiply that by the derivative of the high. So that would be F prime. Minus, notice we have a difference now, subtraction instead of addition, the high, which is labeled as F, times the derivative of the low. So we're going to multiply that by G prime, all over the low, which is G squared. All right, so back when I was learning this eons ago, it was low d high minus high d low all over the low squared. So notice G times F prime minus F times G prime all over G squared. So let's just apply that so that you can see how that plays out. Okay, so I am going to go to a problem right from your notes and homework. Number 2, and that reads as such. You have f of x equals 5x minus x squared divided by 3x plus 4. So you have something with an x in it divided by something with an x in it. Okay, so this is going to be my high. And there's my low. There. It's a little faint. Make that a little bit more distinctive. Okay, so your high is your numerator. All right, so let's have at it. So then f prime of x equals, all right, we always start with the low, d high, minus the high, d low, all over the low squared. All right, let me move that so that you can see. Low times the derivative of the high minus the high times the derivative of the low all over low squared. All right, so this says low. It doesn't say take the derivative of it. It just says low. So we're going to write down 3x plus 4 times, notice it says take the derivative of the high. So we go up here and we say, the derivative of 5x is 5 minus the derivative of x squared, which is 2x. So we get 5 minus 2x minus the high, which is simply just 5x minus x squared. And it says we're going to multiply that by the derivative of the low, which is 3. All over the low squared. So it's going to say, it doesn't say any derivative, it just says take the low, which is 3x plus 4, and then you square it. All right, so not too bad. We should be able to simplify this in our next step. And so when I read this, I read something times something minus, so here's my wall. Right, as I mentioned, your pluses and your minuses are walls when you don't have a product. Something times something else. So what I'm going to do is I'm going to combine these minus combining these. Okay? And I'll leave the numerator alone. Most mathematicians are lazy like that. So let's see. 3x times 5 gives me 15x. 3x times negative 2 gives me negative 2x rather, negative 2x squared. 4 times 5 gives me plus 20. And then I have 4 times negative 2x, which is negative 8x. Like that. So minus, okay, I need to be careful. 3 times 5 gives me 5x rather, 15x. Then 3 times negative x squared is going to be negative 3x squared. All divided by, notice I'm not going to touch the denominator, 3x plus 4 the quantity squared. All right. I'm running out of. Okay. So you'll notice I didn't do anything with this negative, and I'm fairly consistent because I want to make sure that I'm extremely careful and I don't do too many steps at a time so I don't make any errors. In my very next step, I'm going to distribute this negative to each of those pieces. Okay, up here all I did was just combine these two together. I grouped them, but I didn't touch the negative in between. All right, so let's see if we can finish this off. All right, so this is a little crowded, but I think we'll be fine. Let's see. So in f prime, our derivative or our instantaneous rate of change, our slope generating machine, 15x minus 2x squared plus 20 minus 8x. And again, if I make a mistake, just shoot me an email. I am human. 15x plus 3x squared. So I'm finally addressing this subtraction. Okay, divided by 3x plus 4 the quantity squared. All right, so now it's a good idea for me to combine like terms. If I see x squared, let's combine those. And here, see these two together? Leaves me with positive x squared. So let's see, x squared. I'm gonna move this one up. So then f prime equals, in the numerator, see I took care of that and that. What else? The x's. 15, negative 8, and negative 15, I believe that is negative 8x. So I took care of that, that, and that. And then I got plus 20. And in the denominator, I get 3x plus 4 the quantity squared. And it is incredibly common for mathematicians not to, well, students call it full out. The denominator, so please don't be alarmed by me not doing that in this particular situation. All right, so let me show you another one where the product rule is necessary, and that is problem number 5. Okay, so let's see. For problem number 5, it reads as f of x equals e to the 7x squared divided by 3x minus 8. All right, so I know that this has to be a quotient rule because it's a function. It has something with an x in it, divided by something with an x in it. Okay, so let me write down the rule for the quotient rule. F prime then equals low d high. Right, so the low times the derivative of the high minus the high times the derivative of the low. All divided by the low squared. All right, so let's have at it. The low in this case is 3x minus 8. Like that. And notice it says take the derivative of the high. So that's an e, so let's copy e to the 7x squared times, let's go back in and clean this up, 14x. All right, so the 14x comes from the derivative of your power. minus the high, which is e to the 7x squared, and it says multiply by the derivative of the low, which is simply just 3, all over the low, 3x minus 8 squared. Low, d high, notice this is an exponential function, so copy times the derivative power minus the high, d low, all over the low squared. Okay, so of course you can simplify this further if you so desire. So let's see what we have. Actually, this is pretty much beyond the scope of what I would require you to do. If you can get here, I'm pretty sure I'd be fairly happy.